So now part 3, we're still looking at triangle where we have two sides, one angle, and they're what we call matching. So we're going to use law of sines. Now so far I looked at an example where we had one triangle, we went to check for a second triangle and it didn't work. So the answer was just one triangle. The second problem we did, we used law of sines, and when we tried to figure out the first triangle, we got an error on our calculator, so it was no triangle. So now let's look at this third case. Side B is 2, side C is 3, angle B is 40 degrees. So what's left? Need to find side A. Need to find angle A. So there are the three unknowns. Since two sides, one angle, it's matching, law of sines. So we're going to have sine B over side B, sine C over side C. Plug in everything we know. Sine 40 degrees over B, which is 2. Sine C over C, which is 3. So do a little algebra. So sine C is 3 divided by 2 times sine of 40 degrees. Let's see what that is. 40 degrees sine times 3 divided by 2. Let's say point. Now if we take the inverse sine of this, that'll give us angle C is 74.6. I'm going to go ahead and finish out this first triangle. So I've got angle C. Let's get angle A by simply taking 180 degrees minus angle B minus angle C. So 180 subtract 40 subtract 74, 65.4 degrees. The only thing left now is side A. We use law of sines again. So sine, let's just shortcut. Sine A is 65.4 degrees over A. And we'll just do B, sine of 40 degrees over 2. So A is going to be 2 times sine 65.4 over sine of 40 degrees. Divided by 40 sine equals so we round this up. So now I've got all three. I first calculated C. Then I got A. First triangle. Question is, there a second triangle? Remember what you do? You go back to the very first angle you calculated, and that was C right here. And we're going to have a new angle C, which is 180 minus the triangle 1C. So 180 minus 74.6. Now we don't know for sure whether we're going to have a second triangle. The way we check it is now we know we were given angle B is 40. This new possible second triangle has angle C, 105.4. Let's figure out what the new angle A would be. 180 degrees minus 40 degrees minus 1 over 5.4 degrees. The new angle A is 34.6 degrees. This is legitimate. It's a positive number. That means, you know what? We actually have a second triangle. Matter of fact, we've already figured out the angles. Here's C and A of the second triangle. We know B is 40. So, just to keep everything straight, let's say we were given B equals 2, C equals 3, angle B is 40 degrees. For the second triangle, we figured out the second angle A and the second angle C all I've left is side A. Just use law of sines. We'll just use B here, sine of 40 degrees over 2. This right here is 34.6 degrees. So the second triangle, side A, is going to be 2 times sine of 40 degrees over sine . So let's crunch the numbers here. 40 sine divided by 34.6 sine times 2. Looks like 2.26. Now, fortunately, I have the answers in front of me, and I may have made a math error. That's why I do that, so I don't mislead you guys. Maybe you've already seen my math error. 34.6. Forty is sine B, sine B is 40 over 2. Oh, I got these backwards. Yep. You probably saw that, didn't you? Sine of 34.6 over sine of 40 degrees. All right, see if this looks better now. So 34.6 sine divided by 40 sine times 2, 1.77, which is correct. So bottom line is, here's a case we have two triangles. First triangle, let's try and write it sort of neat. We had A equals 2.83. B was given to us as 2. C was given to us as 3. Then angle A, 65.4. Angle B was 40 degrees. And angle C, 74.6 degrees. But the second triangle, turns out I've got it right here. A is 1.77, B is 2, C is 3. Then angle A, 34.6 degrees. Angle B is 40 degrees. And angle C, so there are two different angles. These were the initial conditions, but there are actually two different triangles that work. Okay, so that's what can happen. I'll go way back to the previous lecture. When you have one angle, two sides, and they're matching. Use law of sines, but three things can happen. You can have one triangle, no triangle, or two triangles. And I did examples of all three of those. So if I go way back, I have all my notes here. First kind of triangle we talked about, two angles and a side. Law of sines, pretty easy. Then we went to two angles, one side. And we looked at the matching. I mean, one angle, two sides matching. That took a lot of time because you have all this one triangle, no triangle, two triangle. Let's look at one angle, two sides, non-matching. For instance, my example was A equals 2, C equals 4, angle B is 45 degrees. You have to use law of cosines. If you tried to use law of sines, it wouldn't work. You'd be stuck. So this would be our first time to use law of cosines. So here we go. I'll just start with a new piece of paper. So once again, here's a triangle. Two sides, one angle, non-matching. So say we have side A is 2, side C is 4, angle B is 45 degrees. Law of sines wouldn't work. Let's use law of cosines. Now there are three possible law of cosines. However, only one of them is going to work. So I know angle A, I know side A and side C and angle B. Hopefully you can see that this is the law of cosines I should use. Because I know A, I know C, I know cosine B, so I know everything over here, so therefore I have a way to figure out the length of side B. So 2 squared plus 4 squared minus 2 times 4 times a cosine of 45 degrees. Now just be careful that you do the math correctly. You have to multiply all this stuff out here. In other words, 45 cosine times 4 times 2 times 2 equals 11.3137. Now I'm going to subtract that. 4 squared is 16. 2 squared is 4. My calculator didn't mess up. So then b squared is 8.686. Take square root of both sides. You get b equals 2.95. So now, what's left? Looks like angle A and angle C. Now here you have a choice. To finish this triangle, you can revert back to law of sines, or you can use another law of cosines. Now the math for law of sines is easier, but the point is, if you use law of sines, you know, then, like for example, this step, the next step is to figure out angle A or angle C. If you use law of sines, you have to choose which angle to find next. If you start trying to calculate the wrong angle, then you will mess up the problem. So law of sines is a little dangerous because you have to choose the correct angle to go calculate now. And how do you do it? Angle you go basically figure out what is your shortest side, and that's the angle you're going to find. So up here, I'm looking for angle A and C. Let's compare side A and side C. Side A is 2, side C is 4. A is the shortest side, so A is shorter. So we're now going to find angle A. Let's go ahead and do that, and in a minute we'll come back and do law of cosines, and we should get the same answer. So I'm going to find angle A by using law of sines, except what I want to compare it with, I know side B and angle B. So I'm going to do it with B. If I put in everything I know A is 2, B is 45 degrees, and side B so I can solve for sine A, multiply both sides by 2. So I have 45 degrees sine times 2 divided by 2.95. Take the inverse sine. Oops. And you get an angle of 28.6. And then the only thing left is angle C, but of course, now that I know angle A and angle B, and angle B for this problem was 45 degrees. So by the time we do the math, so what's my triangle? A is 2, B C is 4, angle A for 6 degrees, angle B was given to us as 45 degrees, angle C, run out of room. Now if we go back, what happened was, once again, two sides, one angle, non-matching. I had to use law of cosines, and I found side B. At this point, what I did so far, I reverted back to law of sines, being very careful to do it the correct way. If you don't want to have to remember this special rule, you can just use law of cosines again. Let me do that real quickly just to prove to you. So now, let me write down information we were given. We were given A is 2, C is 4, and we calculated side B to be 2.95 by the first law of cosines. So let's go ahead and let's just figure out, we don't know angle A or angle B. If we use law of cosines for angle A, it's going to be A squared equals B squared plus C squared minus 2BC times cosine of A. I know everything here but angle A, so I plug it in. A squared is 2 squared, B squared is 2.95 squared, C squared is 4 squared minus 2 times B, 2.95 times C, which is 4. Very messy math. That's why sometimes people like to use law of sines. So we try and be careful now. Let's combine these two, 2.95 squared plus 4 squared. So 4 equals 7025. Let's multiply these together. 2.95. So if we subtract Negative 20.7025 equals negative 23.6 times cosine of A cosine of A take the inverse cosine .7 degrees. Yep, that's what I got before. Maybe I rounded off a little bit. And then you can easily find angle B by just subtracting from 180. All right, so quick review. Two sides, one angle, non-matching like this. Two sides and the angle, no duplicate letters. You start out law of cosines, in this case to find side B. Once you do the first calculation, then you have a choice. You can finish the problem using the law of sines, but if you do, you have to be careful. The next angle you find, you're going to find the angle opposite the shortest side. If you don't do that, then the answer is going to be wrong. Or you could use law of cosines again to continue to figure out the angle. All right, now we only have one possibility left, one kind of triangle, three sides, and it's pretty simple. So we'll do that on the next video, and then we'll be done with law of sines and cosines.